Hi, my name is James, and this is a Cardano starter kit from Workshop Maybe. I am so excited for this part of the starter kit because we finally get to talk about Cardano. This starter kit began with a little bit of background on GitHub, and we're going to use GitHub at the end of this starter kit. But the focus right now is to dive into a smart contract programming language called Marlowe. Now, it would take a while to cover all of the programming languages that are related to Cardano, but long story short, there's three of them right now. Cardano itself is written on a functional programming language called Haskell, which was first released in 1990. It's a highly secure programming language. The fact that it's functional comes with a lot of benefits, and we're not going to cover those right here. But just know that this is highly secure, highly predictable code that gives Cardano the assurance that it has. On top of that is a general purpose smart contract programming language called Plutus, which I'm really excited to dive into with you sometime soon. All right. But for today, we're going to focus on what's called a domain-specific language built on top of Plutus called Marlowe. Marlowe is written specifically for modeling financial contracts. And the thinking here is that anybody who understands these financial ideas should be able to write a Marlowe contract without being an expert developer. Let's put that theory to the test. And I know that not all of us are financial professionals, but I think we all understand the idea of a bet. So let's try to program a simple bet in Marlowe. Now, one best practice: before you write any code, even if it's, as you'll see, we're not even going to be typing today. We're going to be moving around code blocks on the page, as you'll see in just a moment. But even so, it's always a good idea to sketch out what you're trying to do on a sheet of paper. I know that I can get a little overwhelmed when I'm writing a program, but as long as I have a plan written on paper, I can always revisit that and make sure that I'm going the direction I thought I was going to go. So here's a simple description of a bet. All right, let's see if this makes sense. I called this simple bet. I wrote it on this piece of paper right here. And let's read through this. So a simple bet: player one places a bet, then player two places a bet. Let's assume those are going to be the same amounts for now. Something happens in the world, the thing that they were betting on. Then both players are going to come back to the program, report the outcome, either in favor of player one or player two, and the winner gets everything. Fair enough? That's a simple bet. Now, the one thing I'm going to add to this document here, just to get you thinking about this, is some parentheses. Okay, so for example, everything in this program is going to happen within a program called Simple Bet. So you might see some parentheses like these ones that I just added in pink. Okay. In addition to that, when we think about this mathematical idea of functions, each thing happens inside of the previous. So here's what I mean by that. Player one places a bet. That's the prerequisite to everything else happening, right? So I just added these orange parentheses right here to represent, okay, once player one places this bet, then inside these orange brackets, all these other things are going to happen, right? It's not worth it running the rest of this program if player one never placed the bet in the first place, okay? So just keep that general idea in mind, this idea of parentheses or bracketing, okay, so that one thing leads to another. We're going to see this in action as we dive into the code. So let's go do that now. Okay, so let's take a look at the Marlowe Playground. It's available at this URL, which is linked in this starter kit documentation. And there's a few different ways that we can use it. First of all, you've got 5 tabs down the side right here. We're not going to cover all of these today. And just to expose you to this, one of them is called the Haskell editor. I just mentioned that Haskell is the functional programming language on which Cardano is built. You can see an example of some Haskell right here with some Marlowe embedded in it. Now, if you're new to code, even just that sentence I just said, that might be too much, and that's okay. This is not what we're here for today, although we will be back here someday soon. For today, we're only going to focus on the Blockly code editor. This is such just an ingenious democratizing tool because it allows all of us to come in and experiment with Marlowe code to get a feel for how it works, okay, without actually typing any lines of code. All we have to do is grab code blocks from these menus over here on the left, and we're going to put them together like puzzle pieces in order to write a program. Now, any Marlowe program consists of a set of contracts, okay? There's these partial contracts here, okay? And each one of them has a keyword. So when, pay, if, let, assert, and close. And we're not going to touch all of these today, but we will, of course, use a few of them because these are some of the essential building blocks to a contract. So watch this. There's an action called deposit, and I showed you my written notes on paper about what we hope to happen. Step 1 is that we hope player 1 will place a bet. That's a sort of deposit, isn't it? So let's think about what player 1 is doing. So we have these parameters here in this deposit block. This deposit is going to be made by somebody, in this case player 1, for a certain amount of a certain currency, and it has to go somewhere. All right, so let's fill these things in. The currency part, we go over here to token. That part's easy. The currency is ADA. Actually, you have the ability to mint your own tokens here and start a new ICO craze. But for now, let's stick to the native token. How much ADA? Let's bake this number into the program for now. Let's just say these 2 players are each going to bet 15 ADA. So far, so good. And who's making the deposit? Somebody, a party. Okay. We're actually going to use public key in just a moment, but for now we have a role. The players in this game are called player 1 and player 2. So let's create a role called player 1. I could type whatever I want in that box. Okay. And then where is this money going to go? It's actually going to go to a public key, to a wallet that's not associated with a person necessarily, but it's just a place on the blockchain where these funds are going to be stored, okay? A transaction. And we're going to call this public key our bet. How's that? All right, so player 1 puts 15 ADA into our bet. What's really cool about Marlowe, this Blockly editor, is that all of the blocks we create are easily copy and pasteable. So watch this. I can press copy and then paste to make a copy of this block right here. And that's nice because I actually just want to repeat this code for player 2. I want player 1 to place a bet, and then I want player 2 to place a bet. I want those funds to go to the same place, this RBet public key. And notice that it says over here, into account 0. It doesn't really matter what this number is, as long as they're the same, right? We want both players depositing money to the same place, so then it will come from that place when somebody wins the bet. Now, the reason I did this first is to show you a bit about how Marlowe works. In my mind, I'm thinking these two things should happen one after another. Player 1 should do something, then player 2 should do something, and we should just be able to put those into the contract. But notice it doesn't let me do that, okay? So this is a helpful feature of Marlowe. It doesn't allow me to put puzzle pieces together that don't go together. Now, I mentioned at the start of this video, this is a programming language for maybe non-developers, for people who have financial expertise, but not coding expertise. And the way that this is one example of that dynamic at work, right? This Blockly language is not going to let me do things that I can't do. That would break the program. What I do need to do is use a series of contracts to kind of as the scaffolding for how this whole program is going to work. And a very common sort of contract you're going to use is this when construction right here. All right. When just means we wait for something to happen before continuing. And if you think about a computer program in the real world, a computer doesn't know when to expect something to happen, right? The computer doesn't know when player 1 is going to come along and use this program, but whatever it is, the program wants to be ready to run when player 1 makes this deposit. And now if I try to snap this in here, you see how it snaps in just right, okay? So when player 1 makes a deposit, then we're going to continue by doing something else. All right, cool. Now I showed you parentheses a moment ago. Notice how this contract bracket right here seems to fit around everything else, right? This serves similarly to how parentheses function, right? I'm wrapping the rest of the program in this contract right here. I'm wrapping this deposit in these when brackets right here, all right, to show what it exists inside of. Now, down here, we have some other parameters for this when piece. After slot, and then a number, and then continue. Well, this is our timeout feature. We don't want the computer to wait forever, okay? We're only going to give players a certain amount of time to do each step. Otherwise, we're going to shut down. Now, if player 1 never makes a deposit and a certain amount of time passes, let's say 20 slots, then there's nothing else to do. The program never starts. So what we can do is grab this close contract and just shut the contract down if it never gets started, right? If player 1 never makes a deposit, after 20 slots, just close down. Now, slot is a unit of measurement on the Cardano blockchain. Again, I'm oversimplifying here, and there's a lot more to say about that. I'm really eager to get my hands on the Goguen testnet as Goguen rolls out and as smart contract functionality rolls out on Cardano. We're going to see how timekeeping works on that blockchain, okay? For now, suffice to say that it's measured in these units of measurement called slots, and we're going to let a certain number of those go past before we continue. Okay, so after player 1 makes a deposit, then continue by letting player 2 make a deposit. Of course, notice that this puzzle piece doesn't fit right there. Once again, we need a when contract to wait for player 2 to make this deposit. So, player 1 makes a deposit. Once that happens, we wait for player 2 to make a deposit, and when that happens, we can continue. But what if player 1 makes a deposit and player 2 never shows up? we want to make sure that player one gets their money back. So let's see how to do that. Let's give player two a little bit extra time. Okay. So after player one makes a deposit, player two has to make a deposit within 30 slots of there. Okay. And if that never happens, what should we do? Well, I wouldn't want to just close the contract, because then player one's money would be stuck in this public key, our bet. We actually would want to pay player one back if player two never shows up. So let's look around. Let's see if we can find a way to pay. Ah, that's a contract. Cool. So what I can now do is I can take this pay contract and drop it here. All right. And what this is saying is, if player two never shows up, player one deposits, and then we wait for player two never shows up, we're going to pay player one back. Let's grab this player one roll by copying and pasting. Once again, it's not letting me. Okay, let's see. That's a roll. That's a party. If I want to pay somebody, maybe I need to call that a payee. Ah, look, party. Let's put this here. And then can I put this inside? Okay, sure enough, right? And so you see what I'm doing. That piece didn't fit. So I look for something else, and I'm just going to kind of play around until the pieces fit together. All right, how much are we going to pay player one? We're just going to pay, we're just going to pay back the 15 that they initially deposited. 15 of what? Of ADA. And where is it from? It's from this our bet public key. Notice this, we put it into account 0, so that's where it should come from as well. Cool. Now, if that happens, how do we continue? If player one puts some money in, player two never shows up, then player one gets their money back. Is there anything left to do? I don't think so. So let's put a close contract right there. All right. So now you can see the only loose end in this contract right here would happen if the bet was progressing as we expected it to, continuing right here. So let's keep going. After player one places a bet, then player two places a bet, then they go out and maybe they play a game of tennis together. They play a game of basketball together. They watch something else happen in the real world. Some real world thing happens, and that's what they were betting on. For now, we're not bringing the outside world into this smart contract. That's a great big topic that we're going to be looking at together over the next few months. But for now, all we're doing is we're waiting for player one and player two to have some experience, and then they're going to come back and they're going to tell the contract what happened. We're going to take their word for it. Okay, so we want to wait for that as well. We want to wait a certain amount of time. Let's wait longer this time. Let's wait like 100 slots, because it might take more time for the thing to happen in the real world. Okay, let's wait for them to come back. And what are we waiting for? We are waiting for, let me check my notes. We're waiting for these players to come and report the outcome of whatever happened in the real world. How are we going to do that? Can we use a contract for that? Choice. How about this one right here? Okay, so this block looks like it's allowing someone to make a choice. It's allowing, say, a player, for example, to tell the contract what happened. Let's try this. It fits. Okay, so what are we going to do? The choice needs a name. We'll just call it outcome. How's that? And somebody needs to own this choice. Let's say player 1 gets to choose first. Does that work? Okay. So player 1 is going to make a choice about what the outcome was. What could the outcome be? Well, the outcome could either be that player 1 won the bet. You know, the outcome was in favor of player 1, or the outcome was in favor of player 2. So let's grab a bounds block over here. And actually, look, it already has the numbers we need between 1 and 2, right? The choice is either going to be 1 or 2, and then we're going to keep going. Okay, well, after player 1 makes their choice about the outcome, then we want to let player 2 make their choice as well. So let's drop another choice block into here. Are you surprised that this doesn't fit? Right, okay, so once again, I can see this block doesn't fit. Right, because we once again have to wait. So we wait for player 1 to come back and make their choice about the outcome. Then after that, we wait for player 2 to come back and make their choice about the outcome. But there's a pattern here. I can use a lot of these blocks again, right? All right, both players place their bet. Something happens in the real world. We wait a certain amount of time, 100 slots, and we wait for player 1 to come back and make a choice about the outcome, and then for player 2 to come back and make a choice about the outcome. And then finally, we are ready to say who won the bet. Now, how are we going to do that? Let's see. Well, we've got this outcome variable. We've got player 1's choice for outcome, player 2. Can we just figure out if those are equal to each other? Right? If the two players agree, we're in good shape. If value this is equal to value that, if player 1's choice is equal to player 2's choice, then we're good. But where are those choices held? They're not actions. The actions collect the choices. Observations look like they're comparing different variables. We have these value. Oh, look at this. All right, one of my value blocks is called choice. Let's see. And that can fit there. Oh, let's see if this works. Okay, so choice, it was called outcome, right? Outcome chosen by player 1. Cool, that works. Can I copy this whole block right here? Cool. Okay. Is the outcome that player 1 chooses equal to the outcome player 2 chooses? In other words, are they both reporting the same thing? Huh. But I have nowhere to put this yet. So let's see. We need something else. Here's an if. Okay. Okay, so we're not waiting right now. We actually want to see. We've collected these choices. We're not waiting for anything else after these choices have been submitted. We just want to find out if those choices were the same. So let's pop an if contract in here. This is the part where the computer just gets to do its work. And it's going to check if these two outcomes are the same. That looks good. If those outcomes are the same, then we can keep going by paying somebody. Who are we going to pay? Well, we're going to pay whoever. We're going to pay player 1 if both people said 1, and we're going to pay player 2 if both people say 2, right? That's another if they said 1 or if they said 2. So let's grab another if contract. Can we click that in there? Sure enough. Okay. And because we've already checked that they're equal, it doesn't matter if we talk about player 1 or player 2. So let's see. Let's just use player 1's response to the outcome, right? if that's equal to this constant, if that's equal to 1, if both players say 1, then who gets the money? Well, we're gonna pay somebody. And we actually already used a pay constructor right here. Can I just use this again? Pay contract. I'll make a copy of that. I'm going to scroll back up the page. Can I drop this in right here? If both players say the same outcome, and if that outcome is 1, then pay player 1. But how much? Not 15 anymore. This time it's going to be 15 plus 15. There we go, 30. And once that happens, then we can close the whole contract. Now, if the outcome is not equal to 1, it must be equal to 2. So this is where this else statement comes in. Let's drop this in here. If the choice, if the outcome was not 1, then we're going to pay player 2 30 ADA. Good. And we're paying from account 0. That's good. And once we pay, the bet is over, right? We've checked off everything in this document that I wrote here, my notes to myself. We took deposit from player 1. We took the bet from player 2. We waited for player 1 to tell us what happened in the world. And then once player 1 reported that outcome, player 2 reports the outcome. We check that they agree with each other. If they agree, then we just look at, okay, what player 1 says is that it was choice 1. If it's choice 1, player 1 gets the money. Otherwise, player 2 gets the money. Good. I see a loose end here, so let's just grab this close contract and make sure we're closing things out as we go. Okay. Close. What are we closing here? We're closing. And you can see this is where it starts to get a little complicated to navigate. I'm excited that I have my sheet right here with my different parentheses on it. This when is wrapped around this. This is where we start waiting. And if nobody ever submits an outcome, actually that's not quite right for the contract to close, but that's the problem I'm going to hand off to you in just a moment, okay? Let's make sure that everything works so far, and then let's come back and think about what should happen when certain outcomes don't happen. We're going to do that in just a minute. But before we do, let's see how we can now play with the code we've written already. To do that, I'm going to send this entire contract to the simulator. What happened? An unexpected error has occurred. Position 8. Okay. And I did this on purpose for you. This happened to me the first time I wrote a Marlowe contract. And long story short, the names we give things can't have other punctuation in them. Okay. So remember how I wrote these dashes in the public key our bet? Dashes aren't allowed there. Okay, so let me get rid of those dashes in our bet. It was hard for me to understand what that error meant exactly, but through a little trial and error, I figured that out. And now that I'm getting rid of all those dashes, all right, we should be able to send this to the simulator now. Let's give it another try. And sure enough, there we go. All right, check it out. What this does is when we press send to simulator, our code blocks are translated to written code. And if you read through here, you're going to recognize in the words that are typed here, the code that's written here on the page, you're going to recognize the blocks that we've already created. I'm not going to go through that step by step right now, but I do encourage you to take a scroll through here and see how much sense this makes. What I do want to do is simulate this contract. And over here on the right-hand side, I have this actions pane, all right? And I'm going to switch to the logs tab on the bottom of the page. I can scroll this up so I can read along with these actions and what happens. Well, let's look at basic functionality here, okay? The first action, this shouldn't be surprising to us, is that player 1 has the opportunity to deposit those 15 units of ADA. I could also just move to, say, slot 40. Watch this. And if I do that, nothing happens. We're done. Nothing else can be added. That's because we only gave the players 20 slots to start playing the game. So I just typed a number bigger than 20. The whole program ends right there. All right, so let's not do that. Let's actually use the functionality that we've got here. We have player 1 depositing 15. And notice down here in the logs, we see deposit 15 ADA into our bet as player 1. The next thing our program allows us to do, and this matches what I wrote on paper earlier, is player 2 gets to make a deposit or place a bet. Cool. Now, what if a bunch of time passes? Let's pass 200 slots right here and watch this. Okay, look. So after those bets were placed, we said we're going to wait 100 slots and then close the contract. If that happens, check it out. Right? If both players place a bet and then 200 slots have passed, the contract has paid out that ADA to this our bet transaction right here. Okay, so now the money is stuck. That's not good. We're going to want to fix that eventually, but I'm just showing you how this contract works so far. We're going to want to deal with this later, but I'm going to make that your problem in just a moment. All right, let's see. All right, so again, player 1 can place a bet. Player 2 can place a bet. Then each of the players are prompted to submit an outcome. If player 1 says value 1, that's not ideal. Let's see. Player 1 chose 1, but it never gave player 2 a chance to submit their choice. When player 1, okay, then we wait for player 2. How long did we wait? Oh, we waited no time at all. That's no good. We need to wait a certain amount of time. Let's just make this 100 slots as well, just to be generous, okay? We need to wait a certain amount of time after player 1 places or submits their outcome. I have to go reset the simulation because I was right in the middle of it. Let's reset. Let's go back to Blockly. Let's send this to the simulator again, and let's see if it works this time. All right. Player 1 makes a deposit. Good. Player 2 makes a deposit. Good. Player 1 says the outcome is 1. This is where our contract stopped last time because we had zero slots to wait for player 2. All right. So now we're still going. Now we are prompting player 2 for their outcome. Let's see. If they say the same thing, they both say 1. Who gets the ADA? Player 1. How much do they get? They get 30. All right, that's what we want to happen in a bet. And I can see all 5 steps that I wrote on paper earlier. Let's reset. Let's try letting player 2 win. So player 1 places a bet. Player 2 places a bet. they each say that player 2 wins. So player 1 and player 2 both say the outcome is 2, and sure enough, player 2 gets rewarded for that. Nice. All right. This is basically working. But there's a problem here. What if the players disagree? What if player 1 says I won and player 2 says I won? Then what happens? The contract pays 30 units of ADA to the our bet transaction. Okay, so the problem now is that if the players disagree, their money is trapped in this contract. And we're going to have to fix that. Interesting. All right. So what have we covered so far? This is the Marlowe Playground. We can use Blockly, this Blockly editor, to create a contract. We notice that each successive part of the contract is embedded in what we've already written, right? We've got all these different sets of brackets or parentheses wrapped around things. Whoops, I just moved that out. Okay. And we've got a contract here that basically works as long as we have trustworthy participants, right? But as soon as there's disagreement, this contract can't handle that. And we're going to want to fix that. That's my challenge to you. So in the next part of this starter kit, I'm going to hand this code off to you so you can play around with it and try to fix some of the limitations that I've left you with in this simple bet program. All right. I'll see you there in those challenge exercises.